Hey folks, AJ here, CEO of Snapser. We're going to continue down our Snaps 101 series, and today we're going to look at the storage snap. In my opinion, a lot of applications or games, all they need is the authentication and the storage snap, and they can go a long way. In fact, some people can even release their games with just these two snaps. And in that sense, storage is a very fundamental snap on Snapser. It's also fully comprehensive in the sense it comes with different blob categories, it comes with different security measures, it also implicitly comes with optimistic concurrency control, which prevents two devices from stomping on each other. In this demo, we're actually going to focus on the basics. So we're going to focus on how you can, use the storage snap and store information about the user's game or application in the cloud. We're going to also then look at the optimistic concurrency control. In the subsequent demos, we'll dive deeper into the different security measures that the storage service provides, along with the different blob categories. So let's jump right in. As you can see, I've already built a backend with authentication and storage. I've also gone in and enabled anonymous login and created one user, which just allows our demo to move quicker. So I'm going to now go to the snaps configuration and pick the storage blob keys. Now you may ask, why is Snapser making you add an explicit blob key so that you can then store information? Well, it's honestly to prevent bad actors from polluting your own backend on Snapser and polluting your data stores. So you have to go and create a blob key, and only then you can your client devices can store data against the blob key. So let's go in. And imagine we want to store the user's world. The user has a game. The client is continuously the user is actually interacting with their game, and the client wants to keep updating their world state with the cloud. That's the blob key, which I'm calling world. Additionally, as you can see, the storage snap comes with different categories of blobs you can store. It also comes with different security measures. We'll dive into that later on in different videos. For now, I'm just going to go with the basics. So I'm going to go ahead and hit save here. And that's pretty much it. Once you have this blob name or blob key, you can now start storing information about using the APIs. And also, one thing to note, it's not just one blob key. You can create as many blob keys as you want, and you can start storing different kinds of information in these different blobs. So let me jump into the API Explorer, and we're going to take the storage blob save for a spin. So you can use the replace blob API, and here, as I told you at the start of the video, I've already gone in and created a user account so that this video can move quicker. I'm going to copy the user's ID, and I'm going to copy the user's token. Mind you, you need to be authenticated in order to store information, and the access type is protected, and the blob key, as we entered in the previous form, is called world. Now let's look at the payload. The cache value is what I meant by saying that the storage snap supports optimistic concurrency control. So it's probably a good time to explain why is that important. Just imagine, you're playing a game on your iPhone as well as on your iPad, and you've now picked up your iPad. You're making changes to your world. The client is syncing that information to your backend, and everything's good. But then what happens if today you've picked up your iPhone after a long time? It locally had a very different state from a time perspective, and by mistake you don't want that iPhone device to go and stomp over the progress of the data that your iPad has stored. And that's precisely why the storage snap comes with CAS, which stands for check and set, which means every time you update data to your backend, you will in return get a different value, and on every subsequent update, you have to pass in that value. Otherwise, the backend won't accept it. It's also important to note that it's fully optional. There are some developers who do not want optimistic concurrency control, and Snapser does not force your hand to use it. But let's take a look at the power. So, since it's the first save we're doing, we're passing created equal to true. You can pass in any cache value, let's say 100. The first call does not matter. Let's not add any TTL right now, and let's just call this user a world. Right now, this part, which is the value, can be any information that you want to store. It can be any kind of, it can be a string, it can be a JSON object, it can just be binary data. If you're happy with this, let's hit put. And there it is, our data has been stored and the backend has given us a cache value that we need to now hold to it. We need to save it locally on our device such that we can now use this for every subsequent updates. So let's say now you come in and you want to now update the value. I'm going to now copy this new cache and I'm going to now update the value to be first update. Let's see if this works. If I hit put, there it is. There you go. Now I have a new cache value, mind you, which is going to be completely different than this cache. It's not also an auto increment, it's a new value. You have to store it locally. I'm going to now store it. Now imagine what has happened is your iPhone, as my example stated before, had a very different or a very old value of your world, and it had, let's say, a random string like this as the cache value, which was old. It also had an old user blob that was stored locally. So this is my old world, and let's see how the cache now prevents a bad update from happening. So let's say I have a bad cache value. I'm actually going to do this. Let's say this is random. Let's say 5. So it's incorrect. And I hit put. There it is. It now says that you have a completely incorrect cache value. And so the backend is not going to allow you to store it. On the other hand, if I now change it back to the correct value, I can now go and do my final update. There it is. And now it's here. You can obviously use the get blob to retrieve this data as well. Let's again copy the ID of the user, the token, the access type was protected, and the blob key was world. If I now retrieve this information, there it is, the final update has come to me. So hopefully this gives you a good idea on how to use the storage snap. You can be up and running very quickly. Just add your blob key and just start storing information in the cloud. Now, if you do not want optimistic concurrency control, you can pass in a special cache value of 0, which tells Snapser to not really care about optimistic concurrency control and always just update the value that is present in the cloud. So if I run the force update now with a cache of 0, it will allow me to do that. And now if you go to my get blob, you will see that the value is the force update value. So it's definitely not required for for developers to use cache. But it's definitely highly recommended, especially if you have a multi-device application or game. Hope you enjoyed the video. Let us know what you think. Thank you.